In this lesson, we'll introduce the IRR and the XIRR functions as we discuss rate of return analysis. Rate of return analysis is the third technique we're going to discuss that can be used to solve capital budgeting problems. And so the internal rate of return, or the IRR, is the discount rate that makes the net present value of all cash flows from a project equal to zero. In some sense, the way to think about the IRR is that it's the annualized return for a given project, okay? And generally speaking, we prefer projects that have a higher IRR. In Excel, there's a function, the IRR function, that once you give the cash flow values, it returns this discount rate, okay? A few more things on the IRR. Okay, so the IRR will have different interpretations depending on the form of the cash flows. And so for investment streams where first we invest money, so there's a negative cash outlay, and then this is followed by a switch so that we have positive inflows, okay, the IRR it's called the rate of return on the investment. Whereas when we borrow, or when we have a borrowing stream where first we receive some positive inflows, positive cash flows, and then we switch to paying them off, so there are cash outlays, the IRR is called the rate of cost or the rate of financing. And so in the first case, where we have an investment, we want a high rate of return. We want a high IRR. Okay, whereas when we are borrowing and we have to pay back the money, we want a low return. We want a low IRR. There are actually two functions that we can use to calculate the internal rate of return. One is the IRR function, and with this function, you give the values and then a guess, and I'll talk about what the guess means in just a little bit. And this is going to be the function to use when the cash flows are laid out kind of in a tabular format in Excel. When we have regular cash flows, so we have an annuity where we have an initial investment or a loan amount, then we can use the rate function. And in the rate function, as we have used before, we have the number of periods, the payment, the present value, and then we can put in a future value, and then we have an option to guess. And this is because for both of these, sometimes there are multiple routes, right? There are multiple discount rates that actually set the NPV to zero. And we'll talk more about that in a subsequent lesson, okay? When you have, whenever these functions return a num, it means that it tried to find the rate of return, but it couldn't converge on a value. And you will see how, for these calculations, sometimes the functions are highly nonlinear, and so it may not be able to find the internal rate of return. So let me actually show you how to do this with an example. In this first example, we have what's called an investment stream, okay? And so what this means is that we are making an investment and then getting returns in the subsequent years from this investment. To calculate the rate of return, we're going to use the IRR function and give it the transaction values. And so here we get that the IRR is 7.71%. And so we know that for any rate that is below the IRR, the NPV is going to be positive, okay? And so if we calculate the NPV here with an interest rate of 5% and then give it the values starting in period 1 and then adding the cash flow at time 0, we're going to get a positive NPV. Note that if we set this to be equal to the IRR, we're going to get, as by definition, an NPV of 0. So now let's actually discuss what an investment stream looks like. And it doesn't have to just have one investment, right? You can have multiple periods where you have investment cash flows, and then you switch, and then you have returns thereafter. And so what's important here is that there's only one switch here. Okay, we invest some money and then we get returns from it. And if we were to plot the net present value as a function of the interest rate, okay, what we would find if you just have this one switch from negative to positive is that there is a unique IRR, a unique interest rate that makes the NPV equal to 0. And so we can use this information to help us decide whether a project is viable or not. And so we know that if the interest rate is below the IRR, then we're going to say that the project is viable. And what this means is that when the interest rate is lower than the IRR, it means that the returns from the project exceed what we would get if we invested the money at a rate of VAR. In other words, we could not match the cash flows from the project, the returns from the project, if we invested this money at a rate of VAR. And so for that reason, if we have the rule, if our interest rate is less than the IRR, we're going to say the project is viable. But if the interest rate is higher than the IRR, we're going to say the project is not viable, right? Because if we're getting a higher rate of return, we could invest this money and then exceed the returns from the project.